pretty deep.
Hello, hello.
Thanks everybody for being here. Thank you to Messari for inviting us. We're going to have two virtual presentations from Danny and Poojah. Poojah first, then Danny, then followed by Piper. And just a disclaimer, though three of us work for the Ethereum Foundation, this isn't anything presented here or the discussion afterwards is our views personally. It's not the position of the foundation. So I think we could probably just kick it off right there. Poojah and Danny, just make sure to introduce yourself.
Hey everyone, I am Poojah Ranjan from the Ethereum CAT holders. So today I am going to be talking about the upcoming proposals. Let me just quickly share my screen. Suppose it is visible now. So today I'll be going to talk about network upgrades, provide an introduction to upcoming proposals, and share some resources to learn and where to participate. Let me start by providing you a big picture of Ethereum network upgrades. So this is a representation of network upgrade timeline based on my understanding following the information that is available. In the past 6 months, Ethereum deployed 2 successful upgrades on the mainnet, and we expect at least one more on the proof of work chain by the end of 2021. It's really incredible in itself to have a 3 coordinated upgrade in a year on the biggest decentralized blockchain. The name of the upgrade is not quite clear yet. I mean, there can be some changes depending upon the number of proposals that gets in. So if this is just the representation, and if there would be more than one proposal to push the difficulty bomb and more proposals, then the name can be like Shanghai, Cancun, and Prague. You can see the name changes. Similarly, the beacon chain that we have started in December 2021. It is expecting its first upgrade in October this year. Danny Ryan, who is here to speak right after this presentation, will be talking more about it. I just want to share one fun fact here. The name of the proof of work chain on Ethereum network is decided based on the DEFCON, the places where we have DEFCONs, and for beacon chain, that is dependent on the alphabetical order of star names. I hope you find this information interesting. Moving on, this is the list of proposals deployed on the Berlin and London upgrades. In total, we had 9 EIPs. Those were deployed to bring improvement to the performance and security of the chain. I would like to bring your attention to the futuristic approach of the client development team and the selection process of the proposals for an upgrade. Here, the EIP 2718 and EIP 2930, those were required for EIP 2929, but were also needed for EIP 1559, a proposal that the Ethereum team has been working for over a year of time. And similarly, proposal 3541, which was deployed in London, is the stepping stone for another proposal that is for EVM. The number is 3540, which is expected in the next upgrade. And we'll be talking about this proposal in upcoming slides. All the information about the Ethereum mainnet upgrade is available on GitHub. I'm provided the link here. Moving on, EIPs for upcoming upgrade. We are starting with EIP TBD. This is for pushing difficulty bomb. The proposal is expected in late November or early December. However, it is not documented yet. We hope to have a formal documentation very soon on EIP's GitHub when we get more clarity on how far this difficulty bomb needs to be pushed. Difficulty bomb is a set of codes added to Ethereum blockchain to raise the difficulty level exponentially, making it difficult for miners to keep up with the increased difficulty. It also increased the block time, and it feels like the blockchain is going to freeze. So it is also known as the ice age. Basically, this difficulty adjustment process was put in place back in November 2015 to ensure that everyone who wants to continue the Ethereum main chain must upgrade. The first proposal is listed here is EIP 100, which was proposed by Vitalik Buterin in April 2016. And the one that we are expecting in November, December, this is This will be a successor for the EIP 3554 difficulty bomb delay to December 2021. EIP 2935 is documented by Vitalik Buterin about a year ago. This EIP proposes to store historical block hashes in a contract and modify the block hash opcode to read this contract. As I understand, Nethermind, one of the ETH1 client, has already implemented this proposal, and Tomas Stanzak, who is the lead developer of Nethermind, is championing this proposal. This EIP is up for Shanghai, but an important note here is that the EIP is not intended to be permanent, and when we have like merged the ETH1, merged with ETH2, the block hash opcode would likely use the ETH2's built-in history accumulator structure. What it means is like if Shanghai is after the merge, this EIP probably will not be able to make the final status, but that nothing is set in stone yet. Nevertheless, this is an interesting proposal. If you are interested to learn more about it, links for the EIP and the recording on informative episodes is provided in the slide. Coming up next is EIP 3540 about EVM that I mentioned earlier. So we are having this discussion of EVM and account versioning over a period of time, and there is no predefined structure today on the on-chain deployed EVM bytecode, and these codes are typically validated in clients every single time prior to execution at runtime. And this is like tedious process, and it's quite challenging to introduce new features or maybe deprecate the existing features. So Alex, Pavel, and Andrea proposed this proposal in March 2021, which will introduce extensible and versioned container format for the EVM with once-off validation at deploy time. The full implementation of this proposal is dependent on the EIP 3541, which is to reject new contract code starting with the 0xCF byte, and that is already deployed in the London upgrade. Again, links to the resources as well as to the proposal is added here. This is the list of a few other proposals which are up for Shanghai, and we may expect more. This can be followed at Ethereum PM GitHub. The merge. This is the next biggest upgrade coming up on Ethereum mainnet, where the consensus mechanism will shift from proof of work to proof of stake. The specification of the change is being documented in EIP 3675. The EIP proposed by Mikhail, Danny, Vitalik in July 2021 is still in draft status, which is literally the first approved status for any Ethereum improvement proposal. However, many tests are being conducted, and we can expect developers testnet to test the merge specs on both the execution chain and the consensus chain. And if people remember the reunion that was organized in summer, that is a major achievement towards this path. Even though this proposal is in early stages of being a standard, it is already populated with a lot of information. And for people interested to learn more, there is this merge checklist available that displays if how ready merge is. And we have also added the resource for the overview of the proposal explained by one of the authors. So that's all about the proposals, and we may hear more on merge with Danny Ryan. So people looking for resources, this is the list. You may follow these GitHub repositories and start contributing. Thank you.
Thank you, Poojah.
Thanks, Poojah.
I think I'm next, right?
Yes.
Y'all can see me? You can hear me? Okay, let me share this screen. All right, cool. Thank you, Poojah, for setting that up. I'm going to talk to you about the merge and a journey through diagrams. So again, the merge is the deprecation of proof of work for proof of stake for Ethereum mainnet. It's called the merge because at the start of December of last year, the Beacon chain was launched, which is Ethereum's proof of stake consensus mechanism, and it was launched in parallel to the existing proof of work chain where all the activity happens today. And so the merge is the unification of these two systems, the deprecation of proof of work, and kind of combining the things that we know and love about Ethereum: transactions, state, account, all that kind of stuff, MEV, NFTs, CATs, and stuff, with proof of stake, the Beacon chain, which we consider a more secure, sustainable, and scalable consensus mechanism for the future of Ethereum. So I'm going to talk to you a bit about what that looks like. It's actually not that scary. It's actually relatively simple, and it actually, the implications for users are minimal. Applications continue to work, and users and software continue to exist. And I will help you gain an intuition for that through some of these diagrams I made. So first of all, actually about a year ago, I gave a talk, ETH1 plus ETH2 equals Ethereum, and have been trying to kill the terms ETH1 and ETH2 since then. Really, what are these things? ETH1 is a proof of work consensus mechanism along with a very robust, highly optimized application layer, execution layer. And what is ETH2? It is this proof of stake consensus mechanism. And so what is ETH1 plus ETH2 equal Ethereum really mean? It really means take ETH1, take this proof of work chain, strip out proof of work, retain that execution layer that we know and love and care about, and give it this new consensus layer, this new proof of stake consensus layer. And so when I say ETH1 plus ETH2 equals Ethereum, I mean the execution layer of the chain that we know and love, and the consensus layer of the Beacon chain is Ethereum of tomorrow. So let's take a look at what that actually looks like in terms of these nice diagrams I built for y'all. So what does Ethereum look like after the merge? That's it. Boxes. It's a blockchain. After the merge, Ethereum looks like a blockchain, and that's what it looks like before the merge. And it actually is relatively simple. Like, transactions are still in these blocks. Everything's still built. There's a state, there's execution, and there's a consensus mechanism. And from the end user's perspective, I have transactions, I have accounts, I have contracts, and they all live in this chain. So, and it's a bit, that's it, simplicity. Let's drill in. So when I say it's simple and it's a single chain, really we have this kind of consensus layer cradle. And then we have the execution layer inside of that cradle. And so we have this blockchain where we have proof of stake consensus that's helping drive and kind of control and direct things from the outer layer. And then we have this execution layer, which again is kind of where users hang out, has transactions and state and all the things that they love. And that looks and feels very similar to a proof of work cradle that we live in today. Drill in again, enhance, enhance. So what does the consensus layer look like? So we have these outer consensus messages. This is where the validators kind of hang out. They dictate the slot, the parent root. They have a signature. That's kind of like the proof of work seal. Randomness generation. They put some graffiti in there. You can tag it with 32 bytes, whatever you want. Some attestations, which are core consensus messages. This validator signaling what they think is the head at any given time, deposits, exits, and stuff. Then we got the execution layer, and this looks exactly like Ethereum ETH1, you might call it. Looks like today. You have parent hash, you have a state root, you have the base fee of 1559, you have all these transactions that get executed. And the sequence of the world state is the computing of these execution layer states upon block payloads upon each other, and the consensus layer state similarly is the taking of all this metadata and executing all of these consensus layer messages on it. So we have a nice separation of layers. And in fact, I noted that this execution layer has a parent hash. And so not only is there a parent root in this outer consensus layer, but there's actually like this chain kind of subchain happening in here, which is kind of weird, but it's actually kind of nice. And we'll drill into why that is the case. Because we can take the execution layer or the consensus layer out, say I don't really care about the Beacon chain, I just care about like the things, counts and transactions and stuff. And I actually have this like chained notion without even, once I strip the consensus layer out. So look here, we have the consensus layer, but I can actually just pay attention to this execution layer. The consensus layer is giving me directives, but I'm following this thing I care about. And actually this chainedness is exactly what we see in the proof of work chain today. And that will come into play in a further diagram. So there's the further diagram. What does Ethereum look like today with proof of work? It looks a lot like what it's going to look like in the future. It has a consensus layer. It's not the beacon chain. It's not validators and proof of stake, but it's proof of work. And really, what is that? That is the computing of those hashes and essentially sealing the execution layer contents with a proof of work seal. And we have these hash references, which we had in the post merge, and we even retain in here. And so really, the payload of what we care about in the execution layer is precisely the same pre and post merge. Very nice for many reasons. We can get into that. So Ethereum after the merge, what does the beacon chain look like? It is actually pre-merge too. Pretty much like there's all this, the consensus layer things, and then there's a bunch of space. What do we want to do with the consensus layer? We want to come to consensus on stuff. What do we do at the merge? We shove in the execution layer of Ethereum. So again, Ethereum after the merge, it's simple, right? We all got it now. So again, consensus layer, execution layer, drilling down into its constituent parts. Well, let's look at Ethereum today. I mentioned earlier that we have this proof of work chain, and it holds the execution layer of Ethereum, and it's really where all the user layer activity is happening today. And then we launched this thing called the beacon chain in parallel, and that is, it gets deposits from this proof of work chain, but otherwise it has a very loose tie. It's pretty much a proof of stake consensus mechanism just existing on its own, powered by ETH, secured by ETH, and primed and ready to go for the Ethereum ecosystem to come to consensus on stuff. So again, we got all this space. Hopefully further down the line, we're going to use it to come to consensus on stuff. So that's what it looks like. Two pieces of software, two related protocols operating in parallel. Now this is the fun one. So we have the execution layer. The execution layer references itself with that parent hash. And before the merge, we have these two systems running in parallel. Then at the merge, all this space that we wanted to fill and come to consensus on stuff with, we come to consensus on the execution layer. And so from the user's perspective, they don't care about this cradle. Like their software cares because their software is going to perform this upgrade and kind of forget about proof of work in favor of proof of stake. But from the user's perspective, they're hanging out in here. They're hanging out in here. And the next thing you know, upon some transition conditions, which would likely look like a terminal total difficulty that dictates this transition, they're now hanging out in here. And so their reality is unified and structured through this execution layer chain that remains stable through the transition. And so the validators are hanging out. They don't have a payload to build yet. They don't have a payload to build yet for the execution layer. Then all of a sudden they hit this cusp, and they are monitoring this, and they just take over, and they put it in here. And so from the perspective of end users, from the perspective of tooling that cares about the execution layer, from the perspective of contracts and applications, everything remains stable in a more secure and sustainable consensus mechanism. Simple, right? Again, Ethereum after the merge. It looks like a blockchain. There's a lot of complexity on this transition right here, and how the subtleties of who's in charge and when and upon which conditions the transition happens. But from the perspective of the end user, the perspective of existing software, it looks like this unified execution layer chain that just hangs out. It's really kind of this meta consensus layer cradle that gets swapped. And sharding, we have a consensus mechanism. What is sharding? It's really just adding more stuff into this consensus layer payload and adding sharded data and commitments to that sharded data in there, which is in very active R&D. Hopefully see some cool prototypes and testnets by the end of this year. So how am I doing on time?
Another minute and a half.
Fine. Okay, great, perfect. Okay, so one of the really nice things that's fallen out of this architecture decision is that we have two pieces of software. We have these beacon nodes, and we have these execution engines. We have what was previously called an ETH2 node and an ETH1 node. And what is an ETH1 node? It's a highly optimized handling of the execution layer, transaction, state, execution. And what is a beacon node? It's a highly optimized proof of stake consensus mechanism. And really a client post-merge looks like the unification of these two things, where the beacon node, rather than the proof of work consensus mechanism, is the driver, is controlling this execution engine, asking queries about it and checking validity and different things. And the execution engine gets to strip out the proof of work and hang out and do what it does best, is deal with the EVM and state, which Piper will talk about all the fun problems in that realm. And the user APIs remain stable. They still communicate with, call it Geth or Nethermind, and the beacon APIs, if you want to know about validators and balances, also remain stable. It's a bit of a UX problem here. Obviously, like, well, we don't want two endpoints, but it's actually nice. You can take these Web3 libraries, namespace it, point it to the right direction. You got web3.eth, you got web3.beacon. So there are some good and some bad. I think primarily good in the separation of software and separation of concerns, but a little bit of UX stuff to work through and solve here. I did follow the hype and took all these diagrams and made them into NFTs. All of the proceeds of the sale and royalties of selling these NFTs will be distributed to researchers and developers working on the merge chain. So whenever that may be, I think Poojah alluded to Q1. I will defer to her on that. So yeah, if you want to support the merge, go and buy a diagram and put it on your wall or whatever people do with NFTs. Thank you.
Thanks, Danny.
All right. So Danny's going to run my slides for me. Pardon the slight awkwardness here. I'm Piper Merriam. I also work for the Ethereum Foundation. Slide. Today I'm going to talk to you about Stateless Ethereum, which is a research effort that's been going on for something like 2 years now, and the Portal Network. Let's move it on. Cool, one more. So let's define what I mean when I say stateless Ethereum. This is like a really simplified version of what a blockchain is. We've got this thing that we call a state root. It's like the representation of all of the information, all your account balances and NFTs. We have blocks, and when we execute them, they change things, right? Shifting money around, minting NFTs, things like that, and we end up with the post-state root. And so next, so when I'm talking about stateless Ethereum, what I'm talking about is adjusting our protocol for where the information comes from. So all clients in the Ethereum network today exist in this stateful model, this thing on the left side of the chart. Ethereum clients maintain this very large database of state. This is every single account balance and every single thing stored in every single smart contract. And as these transactions are executed within a block, account balances are looked up, modified, changed, and things like that, and then written back to disk. So this is the stateful model of Ethereum clients, and this is a very big, heavy database. When we're talking about stateless Ethereum, what we're talking about is shifting the model of where the data comes from. Instead of clients maintaining a copy of this database and needing to keep it updated as they move through the blockchain, instead, they use this magical thing that we call a witness, which is essentially just the minimal amount of information needed to execute a block. So instead of having a copy of the information, a stateless client would actually have no information about individual account balances. And along with the block, they would acquire the witness from the network as well. The witness has all of the information they would need to execute the block. And instead of trying to look things up from some local database, they use the witness instead to look up information. What this does is it allows us to lighten up Ethereum clients so that they don't have to do so much work up front and ongoing work in order to follow the chain. It allows you to essentially just sort of drop in. Let's slide. So this gets into the why. We're going to jump one more here. So this thing on the left is my kind of mental model for what it's like to be an Ethereum client. Not only do you have to load all of this state up, but you have to carry it with you to follow the front of the chain and constantly pull bags off and put things in them and put them back on. What stateless Ethereum is shooting for is totally shifting this model so that instead of having to pack your bags and carry all this stuff along with you in order to validate and execute blocks and follow the chain along, you can just hop on your cute little stateless Vespa anytime you want, drop into the chain at whatever point you want, pull witnesses down to be able to validate and execute blocks. Maybe you drop out for a while and drop back in, but you shed this responsibility of having to do all of this ongoing maintenance. Next. And the reason that we need to do this is that we're going towards this whole sharded environment where we won't just have one of these very heavy chains going on, but we might have 64 of them or 256 or something like that. This is the biggest machine I could find a picture of on the internet. And it's just not reasonable for our validators to do this for 64 different chains. So we need our validators to be able to use their cute little lightweight Vespas and to be able to drop into whichever chain they want at any time that they need to do their job there, because this is too big of a machine to manage. So this is why, this is sort of the impetus for why we are doing this whole stateless Ethereum thing. It is sort of a critical piece of infrastructure for us to move forward into this kind of sharded environment, as well as just making the job of being an Ethereum client an easier thing to do. Next. Cool. So we're going to touch real lightly on what we're doing and what we need to do to accomplish this. We have basically 3 problems we have to solve. Right now, the total size of the Ethereum state has no economic bounds on it. It just grows and grows and grows. It's not a very good business model to allow people to pay once for storage and then store it indefinitely forever. These witness objects that I talked about that house kind of this minimal amount of state that you need for executing a block, they're actually quite large in the current data model that we use to represent our accounts and contracts and things. So we need to fix that. And we don't have any clean way to impose economic bounds on the total size of a witness. And so today you can actually generate blocks that would generate witnesses that are in the hundreds of megabyte size. So these are the problems that we're working on fixing. Next. We have planned solutions for each of these. They are underway. This is what, I'm not going to go into details of these, but state expiry, vertical trees, and address space expansion are the solutions to these problems that are being worked on. One more here. If you want to take a picture of this, if you want to dig in further, this is the nitty-gritty details of how we're going about fixing these things. This is how we get to stateless Ethereum. We generally know where we're going. There's always possibility of hidden problems in here, but this has been an effort going on with lots of very, very talented and smart people focusing on solving this for about 2 years here, and we're really getting into the meat of it right now. Next. Cool. So now we're going to switch gears and talk about the portal network. Next. Like I said, Ethereum clients are heavy. You're looking at hundreds of gigs of stuff on your disk. You're looking at multiple cores of your CPU running all of the time. Once you install it, you're looking at waiting for quite a while for it to sync up with the chain until you can actually use it. And this is really unfortunate UX, and it doesn't have to be like this. Next. Cool. If we want to really understand why it looks like this, oh, by the way, the heaviness of Ethereum clients is not a shortfall of the client developers. They do amazing engineering work, and Ethereum clients are really, really impressive feats of engineering. The reason that they're so heavy is dictated by the protocol. And there's been this kind of tug of war going on for a long time between the needs of the protocol and the wants of the users. Because we have these things bundled up into the same piece of software. The same piece of software that users use to interact with the network is also the same piece of software that is the foundation of holding our network up and keeping it running and moving. So the developers of Ethereum clients today have been dealing with this tug of war, and they've done a lot to improve things for users. But there's only so far that they can go whenever they have to serve both of these masters at the same time. Next. Another way to look at this is the choices that users have. This thing in the upper left-hand corner doesn't exist yet. Right now, if you want to interact with the Ethereum blockchain, you basically have 2 choices at very far ends of a spectrum. You can run an Ethereum node, a full node, and that thing is heavy. Oop, there we go. That thing is heavy, but also decentralized, which is a thing that we love. And on the far other end of that spectrum, you can use something like Infura, which is heavily centralized, but really, really lightweight and easy to use. And if the internet has taught us anything, it's that people are lazy and they will follow the path of least resistance. So if you look at kind of how people use our blockchain, you do have people using it using full nodes, but these often tend to be people who have a strong motivation to run their own infrastructure, exchanges and miners and things like that. But if you zoom out and just start looking at users and people, almost all of that usership exists in this bottom left-hand corner of the graph using the easy way through. What we are working on with the Portal Network is providing a third option that lives in the upper left-hand corner of this graph, something that is lightweight, that is on par with how easy it is to use in Fura, but also retains those tenets of decentralization that we care so much about. Next. Clients for the Portal Network are going to be lightweight. They should be able to run on very basic commodity hardware, things like Raspberry Pis, mobile, potentially even browsers. We are building clients that do not require long sync times or even really any sync times at all, where you can install them, turn them on, and use them effectively immediately. These clients are going to be running on a network that is designed to scale very, very well, because this is not a network that we're expecting to have only 10 or 20,000 nodes on. We're looking at networks where we want to be able to throw 10 million nodes at it and have the thing just get stronger the more we add to it. And all of these will be able to serve the standard JSON RPC API, which is the foundational element for how people interact with Ethereum. Yeah, this is the Portal Network. It is a multi-team, multi-client effort that is underway right now. Thank you.
Thank you. So yeah, let's jump right into it. So that was a lot of information, some of it really technical. So I'm going to quickly give a summary, and you guys can tell me if I got that right. So first, Poojah gave a summary of what is going to be happening in the next 6-ish months. She's sort of the boots on the ground. She talks to people, the client developers. She talks to the parts of the ecosystems, interfaces between them. And so we're going to have a hard fork or a network upgrade in December that will push back the difficulty bomb. And then there's a variety of EIPs, which are technical changes to the protocol, that will be considered, they'll be spec'd out, and included in a future upgrade. And so she went over a few of them. Then Danny presented a little bit further out the medium term for the merge. I think one thing that is really important to emphasize here, when the merge happens, there won't be any sort of downtime for users. Applications don't have any need to migrate. And I think this is actually a big misconception for a variety of reasons. I think, back in the day when ETH2 was first being constructed, or the consensus algorithm was first being constructed, there were different ways, different approaches that were considered. And over time, people have seen bits of information, information degrades over time, or people have misunderstandings. And it's totally understandable. But today, one thing that's really important to emphasize is that users won't experience any downtime when the merge happens. You had some delightful diagrams of, that switch is basically like flicking a light switch, and the chain switches over to this new proof-of-stake consensus. Applications don't need to go over a bridge. User balances, all transaction history is transferred. And I think that's really amazing, and I'm super looking forward to it. And probably, I know somebody mentioned that there will be test nets in the next month or so, and then we'll move into the testing phases beyond that, longer-lived test nets, making sure we're settling any issues as they come up, and then eventually setting a mainnet release date. And then Piper is talking about these big picture research ideas. How can we address the pain points at the core protocol? How can we improve node access, making it easier to run a node, and make the network actually more anti-fragile, more stable, more secure? So if I didn't summarize that well enough, please come and meet me after. Come up to me, and I'd be happy to discuss it, Piper, as well. So now we're going to jump into a discussion of what the future of Ethereum is. You saw some presentations here, and I think one thing that I'll just emphasize here is that we're just a few people. We're a tiny sliver of the community, and it really is a network of thousands of open source contributors, people who work on the client teams, people who are actively engaged in research. It's not run by any one organization. Ethereum is often compared to, or it's analogized as being the cathedral versus the bazaar, and Ethereum is definitely the bazaar model where you have, many, many ideas that are being worked out simultaneously, and over time these ideas, they're refined and the best ones come forward, and sometimes it turns out that they're not actually the best one, and then you head back into the research phase. So the first question I have for the panelists is, how do you see in the future, given where Ethereum's going, the changes that are coming up, how do you see this cathedral versus bazaar model continuing? Will it continue to be a bazaar? What's your perspective on that? Danny, go ahead.
I'd say that it's only increased the model. I think early on, obviously the EF was like driving a lot of core development before Ethereum launched, and then more and more entities kind of began to take ownership over that over time. And a few years ago, there was probably mainnet maintenance and upgrades, and then maybe like a core layer of research and development, probably focused primarily on proof of stake. Since then, over the past couple of years especially, there's probably 4 major R&D efforts being led by various individuals and entities in very fruitful ways, and then like dozens and dozens of smaller R&D efforts and upgrades both to the core protocol, to clients, experimentation on how to build better clients, not only in the portal network in that kind of way, but actually how to re-architecture clients so that, given the protocols that we have, do things more efficiently. I mean, as someone who tries to keep up with all the things that are going on, it's decreasingly possible because there is so much going on, because there's so many players, both client maintainers, people at the EF, people at enterprise, people all across the globe touching this thing all the time.
Yeah, one of my favorite things is finding a new contributor that I had no idea was working on a project, or they're in some niche working on some really awesome project, and I had never come across them. This is really one of the greatest things to see, because it's new contributors, it's new people that are coming into it. Poojah, do you have a perspective on that, being in your position where you're interfacing with these different people at the grassroots level of the community?
Right, being with the group, the Ethereum CAT holders, which is like a decentralized project management and process improvement group. We are actually a group of volunteers with different expertise, and we are heavily engaged with the Ethereum development team in terms of coordination. We coordinate with the client team and then try to communicate the research and update of these development to the Ethereum community at large. And I see the onboarding for a new person here in this Ethereum ecosystem is very simple. You just have to reach out to anyone in the Ethereum community, and then maybe join the popular discords, the ETH R&D discord or the CAT holders discord. For CAT holders, I can say that it's simplest. You don't have to have development skill. Even if you're a non-developer, you can just join us, look into the meetings that goes around. We have a lot of research meetings, client developers meetings, and different meetings. Look into that, and based on your expertise, you can start contributing. So I think the coordination effort done with the help of different working groups present in the space have been proven very useful.
Awesome. Piper?
I feel like the Ethereum ecosystem is this unique pocket of nobody's in charge, leadership without authority. I don't get to really tell anybody what to do, and if my ideas are bad, then nobody's going to come do the thing that I think we should do. And there's something powerful there. And I think the future of that is continuing to educate people that the doors are open, and if you want to be involved in that process, nobody is standing in your way, and there's no locked doors there to keep you out. Yeah.
Yeah.
Yeah, the top contributors that I can think of across the board are just random people from the internet that showed up, knocked on the door, had some good idea, and started building software. And I know it's easier said than done, but the doors are actually incredible, like comically wide open.
Comically.
Yeah. So bringing it back to maybe more concrete discussion, there are so many topics that, we could probably present here for hours on all the research initiatives and the projects that are ongoing, but let's dial in on one that I know people probably are curious about, but we didn't actually get to touch on. Layer 2. Layer 2 has been talked about for many, many years, and if you're following along Ethereum, you'll know that they're here, or are they not? We're not sure. But I think it's a really important thing to talk about, and especially I think Danny can give a really interesting perspective here on how L2s will become supercharged with data availability shards once we get to that point. Danny, do you want to talk about that for a bit?
Yeah. So first of all, generally when we say layer 2, we mean some scalable subsystem in some capacity that leverages and inherits the security of the layer 1 of Ethereum. And so, what is the sidechain? Probably not a layer 2. It's probably just another blockchain that really likes the layer 1. But a layer 2 really, with some trade-off space is actually inheriting the security of Ethereum. And so the most promising constructions actually for the past couple of years now have been these rollups, both the ZK, the zero knowledge type, and the optimistic type. The zero knowledge type have actually been live for longer than the optimistic type. These have a little bit of a more limited construction because they rely on very sophisticated cryptographic proofs. And so these are often more for exchange and just simple asset transfers and things like that. That is not to say that they will not be more general purpose in the future, and I think there are even some experimental and early ZK rollups that are much more richly featured. But those are online, and we have more than a couple, I believe, optimistic rollups that are online in some capacity today and will continue to come online. Some with a bit of a stripped down feature set, or maybe a bit of a compromised security model that intends to kind of inherit more and more of Ethereum's security over time through adding additional fraud proof mechanisms and things like that. These rollups, though, they kind of sidestep some of the issues with earlier L2 constructions, such as Plasma, and they do this by actually using Ethereum's data. Data availability is a very hard problem, but there are very strong guarantees that the single chain of Ethereum, that proof of work chain, and soon to be a proof of stake chain, that data is available. And so if I just chuck all my L2 data onto that blockchain in the form of like transaction call data, then I can make these pretty rich and secure rollup constructions. That said, Ethereum in a single chain construction has only so much data. What is the block size? What is the maximum block size we're kind of willing to accept there? And so there is the scaling of these L2 systems is bound by the amount of L1 data. And so to supercharge these rollups, which are becoming more and more critical to Ethereum's scaling roadmap, is this notion of creating a market for sharded data that have very strong data availability guarantees. And so, but such that not all of the shards need to be downloaded and processed by all nodes on the network, but you can still have extremely strong guarantees that the data is in fact available. And so this next major upgrade for the kind of proof of stake consensus, obviously there's Stateless Ethereum and other major upgrades going on in parallel. But after the merge, the major upgrade for the proof of stake consensus is to add sharded data and to, as Trent said, supercharge these L2s that scale with the amount of layer 1 data. So if we can get 100 times more layer 1 data for these rollups, then we can get 100x scalability on the rollups that are coming online today, which already give us an order of magnitude or 2 scalability. There's a lot of push it out more than 3-5 years. The scalability story of Ethereum might might continue to grow and evolve, especially with the more tighter integration of zero-knowledge proofs and other advanced constructions. But really, on that 3 to 5 year time horizon, getting a lot of good L1 data and coupling it with rollups is very critical.
Yeah. So again, I'll summarize. And if you just heard 3 to 5 years, that's Danny talking about like other stuff way in the future. But the reality is today we have Ethereum mainnet with a ton of capacity for existing rollups to settle data and transactions back to mainnet. And now there's a handful of really awesome teams that are working on this, but we don't need to wait for shards. We don't need to wait for proof of stake to necessarily have the Ethereum user base start leveraging these amazing projects. Like many of them are live today. You know, they're in there. They've got their training wheels on, and they're slowly getting users, getting liquidity. It's going to take some time to have them really flex their full potential. But today, these things are live. It's rare that there's a day when I don't see somebody exclaiming how amazing the user experience is. And I have a feeling it's only going to improve. But like I said, we don't have to wait for shard chains to be live for the community to start leveraging this. And I think it's going to be really powerful once we bridge that growing pain period where, you know, everybody's used to transacting on mainnet, all of their funds are there. But we have to bridge that, you know, new users might start their blockchain experiences only on L2s, and they never have a need to settle back to mainnet. It's just that in-between period where we're going to have to navigate a bit. There might be some growing pains of, you know, infrastructure for users in terms of wallets, block explorers, things like that. It's going to take some time to navigate that development.
But it's here.
It's here, yeah. Yeah. There's a quote, and I'm going to misattribute it, but the future is here. It's just not evenly distributed. So we're in the middle of it. Just be aware of that. I'm going to pull up one of the questions submitted by the audience. Taylor, whoever you are, thank you for submitting this. And the question is, what will be Ethereum's core competitive differentiation in a world of proliferating L1s with superior efficiency and scalability? Piper, do you want to try to tackle that?
Yeah. It's really hard to find useful metrics, and most of the metrics that people use to try to measure these things are really bad or indirect. I think I gave a whole talk to a business school class of a friend of mine of like just why the price doesn't mean anything at all. Developer Mindshare, which is totally like tooting my own horn, I guess, but like it's pretty easy to start a new blockchain. It's pretty easy to start a new blockchain that is technologically better than Ethereum because you don't have to do any of the backwards compatibility stuff. But the thing that's really hard is getting all of the people who are able to continually work on it, care for it, make it better, to get them to come join together. And that is something that is happening in spades in the Ethereum ecosystem. And that ship doesn't turn quickly. I don't know if I answered the question.
People move slowly. That's what you're saying.
There's momentum there, and shifting that isn't necessarily something that is easy to do or that happens quickly. And that momentum is going in like at least a really good direction as far as I can tell. So yeah. Users, developer mindshare. There's also, I mean, I guess I'll step back for a second and say, I don't think, at least speaking for myself, I don't view it as like, there's no competition. Like Ethereum is going to live and die on its own merits. We're driving towards a vision of decentralized state access, and we're going to keep pushing for that. There are other chains which make different trade-offs, pursuing different goals, and that's fine. But it's not like we're going to compromise on what this vision is just to compete or try to
direct users away from a different chain. I don't think that's in anyone's intent. And yeah, like you said, people, users, developer tooling, all of these things, liquidity, all of these things are really sticky, adding up to network effects that is really hard to move. Danny or Poojah, do you want to add to that?
Yeah, I would echo to you. I think the USP here with Ethereum is the user base. The user base that we have, we are actually not competing with any other chain in the ecosystem. At least that's what I think. Ethereum has started on its own, like just to make an ecosystem for, it's a complete system, not just for transferring money here and there. And now we are seeing that there are many projects being developed on top of it as like L2 or different side chains, but most of them are inspired by Ethereum blockchain. So I don't think we are in competition with any chain as such, but we hope to keep growing with the support of users.
Danny?
Yeah, I mean, I think there's a very deep ethos of decentralization in Ethereum and the unwillingness to compromise on certain things because we think that not only is it good, but it's also robust and also provides immense value to humanity. And so there's just quite simply there's many different types of systems being built out there, and Ethereum's building a decentralized one.
Well said. We've got a few more minutes, so I'll jump back into the discussion. Let's see. One of the things that we didn't get to touch on is future Ethereum clients and how they're redeveloping their current architectures to, become more scalable, better hold state. One of these, maybe you've heard of it, is Aragon, which is formerly called TurboGeth. They've changed to a different state model, and it should be, we don't have really a deep presentation on it, but Piper, maybe if you can just jump in really quick and talk about what they're doing to make running a node even easier.
Yeah, I don't know if I can get into specifics on their model, but it is, maybe they are a really good illustrative example of, I don't want to call it best idea wins, but the ability for our ecosystem to, for somebody or some group of people to come along and say, I think this can be better if we did it a little bit differently, and then trying it, and then doing the work to figure out whether or not that's real or not. And the way that people truly sort of pile on to that as the ideas get validated and shown to not just be wild, crazy, unfounded ideas, but like, oh yes, this is real, and yes, this does squeak out, some amount of performance or like other, marked improvements to the status quo. The willingness to completely rework things and to throw things out if they're not working and to try new stuff.
Yeah, and not double down. I'm reminded of, back in 2018, maybe I should just have Danny tell the story, but there was a direction that ETH2, I think we're calling it ETH2 then, that's no longer the nomenclature, but at the time it was headed in a certain direction, and then the community and the researchers came to a point where they just figured out that this current design architecture isn't workable. Danny, do you want to talk about that and how it evolved to what we have today?
It was probably workable, but it just wasn't good enough, and especially from the decentralization metric. So like EIP 1011 was the initial proposal to get proof of stake onto Ethereum, and the minimum stake requirement was 1,500 ETH, which is a lot. It's even a lot at yesterday's prices, yesteryear's prices. And the amount of validators that could be supported on this infrastructure was pretty massive and was going to have pretty large implications for decentralization. And so the aha moment of being able to utilize BLS signatures and aggregation in a way that supports, on the order of hundreds of thousands of validators rather than thousands or low tens of thousands, was kind of a big moment, and it was a tough decision and a tough thing to kind of steer and rally behind. But we had a 10x, 100x better design, and so that the good ideas won, and that's what we're merging into at the end of the next development cycle.
Yeah. All right, we've only got about 1 minute left, so I will ask the panelists, what is one thing you're looking forward to, either as a research project or something that's being implemented currently? What is one thing you're looking forward to as a future Ethereum feature outside of what you already presented? Poojah, do you want to go?
Well, it's not outside of what we already presented. I am looking forward to the merge because I understand that is going to be like requiring a lot more of coordination effort that we have been doing it for Ethereum network upgrades. Like I understand like Ethereum CAT herders, we have been part of network upgrades since inception, and we have been doing good. EIP 1559 and London was one of the good example of coordination, and I expect to have more coordination needed for merge, so I'm super excited for merge.
Piper?
I think the thing that excites me the most is that we've stopped hunting rabbits and started hunting stags. There's been years of us, there was a while there where coordination was hard and difficult, and there was a lot of just everybody working on their own things. And something significant has shifted in the last 2 years, and now the development community truly comes together, and we've pushed multiple big, significant changes across the line. And we keep doing it, and it's amazing. I think that's the thing, is the willingness to really tackle the big, hard stuff now.
More of the same.
I totally agree, but I don't think we're hunting stags, we're hunting bears.
Okay, big animals either way. Do you want anything besides an animal reference, Danny?
It wasn't just it's a market reference. Come on. There's depth to my joke. I don't know. I mean, I don't pay a lot of attention to the application layer, but when I do, it's always super exciting. There's always
it can be at the protocol layer.
But there's always like that. That's what I'm always excited about. Is like the new crazy thing somebody's going to do next month on Ethereum that like I never would have dreamed of, and that's I guess ultimately. I love hanging out in the core protocol development and research, but just like seeing what people invent on top of this crazy machine is always kind of what gets me going.
Yeah, I guess for myself, 1559 just launched at the beginning of August, and it's not like a huge radical change like introducing proof of stake to Ethereum, but I'm excited to see how we can learn from it being on mainnet and perhaps tweak the mechanism, make it more efficient, and again, even better for users, better UX for the people that are actually using the chain. And with that, we are over time. I want to thank everybody for attending, all of you, and for the panelists, Piper, Danny, and Poojah. You guys are great.
Thank you.
Thanks.
Thank you, Trent.
Thank all of you.
Thanks, Messari, for having us.